All right, so in this video, I'm going to go over the bulk of test 3 review. So if you haven't done test 3 review, then you don't need to be watching this video. My intention is that you complete the test 3 review as much as you can, and then you can watch this video and kind of fast forward only to the ones that you really need, kind of like we would in class, right? A lot of you already had the problems worked out, and then you just kind of paid attention to the ones that you were struggling with or whatever. So make sure you have this review out, and again, go ahead and pause the video and stop watching it if you haven't done the review yet, because it's kind of pointless for you. So, you're not going to be prepared for a test by watching me do the problems. You're going to be prepared for a test by you doing the problems. All right, so let's look over the review for test 3. So first, let's talk about how test 3 is going to work. Test 3 is going to be on Math Connect, like your homework, like your quiz is. It is not going to have the help features, kind of like a quiz, basically. So you can send me an email question if you would like. I haven't decided, but I think we're going to take the test, like y'all are going to take it on your computers, probably in some sort of Zoom meeting. So I haven't decided on that part yet, but just plan on this is definitely going to be on the computer. So a little strange, but that's kind of, where we're at right now. All right, so let's look at number 1. Find the variance of the ages. So one thing to note is that you will definitely need to have out, when you do get to the point where you're taking your test, you're going to want to have your formulas out, and you're going to want to have your charts out. So, sorry, I'm trying to find my formulas. So, I've got this formula chart. Yours should look something like this. Okay, so if you want the formula for variance, remember we have a couple of different versions of that. I know it's been a little bit, but the formula that we used for variance, first of all, variance is equal to the standard deviation squared. We often call it that. So I'm just going to write out a few of these. So number 1, notice we have a table. So what you do is you take value 1 squared times its probability plus the next value squared times its probability. Okay, and then I'm just going to be lazy here and say do that for all of them. Okay, and then once you're done with all of them, then you're going to subtract off the mean squared. Okay. By the way, I guess I probably should talk about how we found the mean to begin with. The mean is 15.5. For the mean, you're going to have to do a weighted average, if you will. So it's value times probability plus next value times its probability, and so on and so forth. So if you're wondering where did I come up with that 15.5, this is how I did it. So if you do all of this, you're going to get that the variance is 1.6075. Okay, I think it was exactly that when I worked it out. And then for part B, if you want to find the standard deviation, you would do the square root of the variance always. No matter which form of variance we're using, you always do the square root when you want the standard deviation. So if you do the square root of that, you're going to get about 1.2679. Make sure you pay attention on the test, especially since it's going to be on Connect, to see how many decimal places it wants. Okay, so that will probably vary from question to question. All right, let's move on to question number 2. Okay, so question number 2 uses the probability distribution that's listed above, and it asks you some various probabilities. Some of them are just can you read the chart or not. So the probability of 2 is just reading the chart. That's listed as 0.3. Okay, the probability of no more than 1. So no more than 1 would mean 1 or 0. So all you do is add the probabilities for 1 or 0. And so that's how I got what's on my key, which is 0.35. Part C is find the probability that no one is in line. In other words, the probability of 0. Make sure you know how to write these probability statements. It's capital P and then of whatever event you're trying to determine. So the probability of 0 would just be what's listed on the chart. The probability of at least 3. At least 3 would mean 3, 4, or 5, right? So it would be the values 4, 3, 4, and 5 added up. And so that is 0.35. Okay, so make sure you know the terminology of like no more than one, or one or more than one. Like everything, when you add a word or change a word, it changes it, right? So no more than one is different than more than one or more. Okay, so you kind of have to make sure you know that terminology. Part E, if we want to compute the mean, okay, we just did this above, but the mean of the x's, remember this subscript just means that's what you're finding the mean of. Again, you just do a weighted average, so it's value times its probability plus next value times its probability, and then so on and so forth. So I know I'm using ... a lot, it's just because I don't want to write it all out, okay? But if you need more instruction on any one of these, if I'm not showing you far enough, you certainly could send me an email and a video of what you did or a picture of what you did or something like that. All right, part F asks for the standard deviation of the x's. So one way is to find the variance and then take the square root of it. Another more direct way is just to go ahead and find the formula and the square root at the same time. So remember, it's value squared times probability plus next value squared times probability, all the way through the list, and then you subtract off the mean we just found squared. And if you take the square root of that, you get right about 1.3. Okay. And then last but not least for this one, if a customer takes 3 minutes to check out, by the way, you might need to read the problem through again, but that's what that chart was telling you. The numbers represent how many minutes it takes people to check out. So if it takes each customer 3 minutes to check out, oh, sorry, no, the chart is how many customers are in line. Sorry about that. What is the probability that it will take no more than 6 minutes for all the customers to check out if they take 3 minutes a person? Okay, so this is just another way of asking you for a different probability. So this is saying the probability of 2 or less. And how I got 2 was because if 6 minutes is the max we want to spend and each customer takes an average of 3, then that means 2 or less is what we're looking for, right? Sorry, 2 or more. Okay, in other words, we can be more efficient, but we have to at least cover 2 people, okay? But we might be able to run through 3, 4, or 5 customers. So it would be, sorry, I need to read my own problem again. So forget what I just said. So let's look at part G again. It says, what's the probability that we will take more than 6 minutes? So it's not 2 included. Sorry about that. This is where you need to pay attention to the wording, okay, which I didn't do on that one. So this is the probability of more than 2. Okay, because 2 people would take exactly 6 minutes, and we're trying to find the probability that it takes more than 6 minutes. So sorry about that. So we actually want to add 3, 4, and 5 together. Which I think we actually already did above, coincidentally, in part D. But we end up getting 0.35. Okay, so sometimes it might not come right out and ask you for the probability, and hopefully you won't, bumble through it like I just did. All right, let's look at number 3. 3 is really, really similar to number 2, just trying to give you some more practice. So I'm going to kind of run through these kind of quickly. Part A is just, can you read the probability distribution? The probability of 1 is 38%. The probability of 3 or fewer, so that's the same as 3 or less, so it's 3 or anything less than 3. So notice if you look at your chart, that includes everything except 4. So I figured out that it would be actually quicker to find 1 minus the probability of 4. Okay, but you also could add up 0, 1, 2, and 3, and you'll still get this answer of 0.96. Okay, but remember you have your 1 minus trick, okay, and you'll want to use that sometimes, especially if it's quicker and easier to do it that way. Find the probability that the standard is exceeded on at least 1 day. So maybe we want to read through the problem. So X is the number of days per year that the air pollution exceeds the standard. Okay, so if we want the probability of at least 1, it is probably going to be quicker. So we need to remember this from our last test. If we want the probability of at least 1, it is much quicker to do 1 minus the probability of none. And so that's what we're going to do here. So that's going to be 1 minus 0.33 or 0.67. Notice on a list like this that's short, you wouldn't have to do it that way. But if you had like 20 values, you're definitely going to want to use that at least 1 trick. So you're not having to add all those up. D, find the probability that the standard is exceeded on more than 2 days. Okay, so the probability of more than 2 means, in this case, 3 or 4, right? So we'll add those up. So 10% looks like. Part E, compute the mean. Okay, compute the mean of the x's. So just like we did on number 2, we're going to find first value times its probability plus second value times its probability, and so on and so forth. Definitely make sure that while you're studying for this test that you know how to read your formula chart. You don't want to spend precious time during the test that you really don't have flipping through notes. So that's why I'm going to still want you to use the formula chart. So you really need to make sure you're familiar with that formula chart and kind of what it says. You need to know, that anytime you see mu that it means average and so on and so forth. You are not going to have time to figure out what all the formulas are. You're going to have to know how to find them and find them relatively efficiently. All right, so part F, same as number 2. We're going to do it all in one fell swoop. So value times its probability, or value squared times its probability, plus next value squared times its probability, all the way up. And then at the end, remember, we subtract off the mean squared. So you should end up with about this. Remember also that standard deviation is describing how far out we're going to go from the mean. Okay, so remember that for what we do later. Okay, so the back part of the first page, number 4. So number 4, I give you kind of a setup. The first thing that I ask you to do is a probability distribution. A probability distribution is just where you take all the information and you come up with some sort of table where you list all the values and their probabilities. So if I ask you to find a probability distribution, what we were looking at on page 1 were all probability distributions. So we've got 0, 1, 2, 3, 4, 5, 6, 7, 8. On your review itself, you could just use that if you wanted. Like, there's no sense in you rewriting all of this. You could just add another column to include probabilities. So here are the values we have. You are going to need to get a total if you're not given one. Notice I gave you one on this one, but if you're not on the test, you just total them all up because that's how you're going to find the probabilities. Okay, so how you find all the probabilities is you just do value over total, right? So if you do that for every single one of them, I'm just going to write down what I got kind of quickly. And make sure that your probabilities on the exam add up to 1 or close to 1. It should only, not be exactly 1 if there's a rounding thing going on. So like it should be pretty close to 1. You should be getting like 0.99 if not 1. Okay, so that's a probability distribution. Okay, also these are probability distributions. Okay, anything where the values are listed and then also the probabilities are listed with them, those are probability distributions. All right, part B. Find the probability of more than 4. So more than 4 would be 5, 6, 7, and 8. So I'm going to add all those up. So I'm going to be real lazy on this. I feel like you can figure this out, okay, especially since you have a key. But if you add up all of those, you're going to get 0.2822. So 4 values there. The probability that a person doesn't relax at all, okay? Or make sure you go back and read. This is telling you the probability or the different number of people that relax a certain number of hours. That's probably a lot different now that you're on quarantine, right? You're probably relaxing and napping a whole lot more. But the probability of 0, according to the chart, is 0.0680. Compute the mean. So, notice I included different kinds of the same type of problem. So, if you're in a time pinch, maybe you don't have to practice all the ones where I ask you to find mean. Maybe you can just practice one of the ones where I ask you to find mean. But just make sure that you know how to do it. Also, make sure you go back and make sure your answer is reasonable. In other words, the mean number of hours relaxing is 3.36, and that kind of makes sense since I have values between 0 and 8, right? It would be very weird and incorrect, by the way, if I got an answer that was outside of the chart. Okay, it should be included in the chart somewhere. And then standard deviation of the x's. So again, value squared times probability plus next value squared times probability, and then all of that, and then subtract off 3.36 squared. Take the square root of it, and you have about 1.97. Okay. So what that means is this would show up in the middle of your chart, and you would go out 1.97. Okay, we would expect about everyone on average to have about 3.36 hours relaxing, give or take 1.97, and then we could go out different levels of that, right? All right, number 5. So we did one like this in class where you had to find the expected value of kind of a scenario, maybe a real life scenario. So we want to find the mean. It's a weighted mean, so you need to run through the list of possibilities, okay? There are 4 possibilities, sorry. The first one is that you lose $20,000. So notice you have to make the $20,000 negative, and you have a 25% chance of that happening. But then the next chance is that maybe you make a $10,000 profit. Okay, that has a 20% possibility. You have a 15% probability of really making it, okay, and having a $50,000 profit, and then breaking even, which means a profit of 0. You have 0 times 0.40. Notice you don't actually have to add this one because 0 times anything is just 0. But if you add all of those up, you end up getting a positive 4,500, which means yes, make the investment. Okay, if it were a negative expected value, then you wouldn't want to do it, right? Because you were going to be expected to lose money. Okay, so remember to take expected value for what it is. In reality, you're not going to profit $4,500. That would mean on average, if you took all the businesses in this scenario, on average they would profit $4,500. But in reality, you've only got 4 choices. You're going to lose 20 grand, you're going to make 10 grand, make 50 grand, or make nothing. Okay. All right, so number 6, you need to recognize number 6 as a binomial. Remember, binomial means 2 choices. Okay, so if there are 2 choices, then we use our binomial formulas off the formula chart, the binomial probability thing. So for part A, if we want the probability of 4, now these are true-false questions, right? So we probably need to kind of lay that out, right? True has a probability of 1/2, the probability of true, and the probability of false has a probability of 1/2, right? Make sure you know the difference between this and maybe a problem where it's not half and half. Like if it were a multiple choice question, right, you wouldn't have a 50-50 shot of getting it right or wrong, okay? So keep that in mind. So the probability of 4 answers correctly would mean, it's been a while since we did this, out of the 10 questions, we're choosing 4 to get correct, and then we have 4 correct and 6 incorrect. Okay, so I'm going to kind of write this down. So this represents our correct choices. this represents our incorrect choices, because it's implied, right, that if we get 4 correct, then we must have gotten 6 incorrect. Okay, and if you work that out on your calculator, you're definitely going to want to have your calculator front and center. You'll get what's on the key, which is 2051. Okay, so think of it this way. Out of 10, we're choosing 4, and 4 of them are correct, 6 of them are incorrect. Okay, so let's keep that up and look at a different one. So the probability of fewer than 3, I'm going to write this out, would be the probability of none, 1, or 2 correct. And each of these are going to have their own individual combination formula. So I'm going to kind of write out what they are, and then I'll kind of underline them. So for 0 correct, it would look like this. It would be out of 10, choose 0. 0 are correct, which means 10 are incorrect. Okay, so this right here is the probability of 0. Okay, so we have an answer there, or we're going to get an answer there, and then we would do the probability of 1 correct. So out of 10, we're wanting to choose 1. So we have 1 correct and 9 incorrect. So this would be the probability of 1. And then last but not least, out of 10, we want to choose 2. So we have 2 correct and 2 incorrect. But again, make sure that you go back and look at the notes for this one, because it's only half and half because it's a true-false question. Okay? If it were a multiple choice question, for instance, with 4 choices, you would have a 1 out of 4 chance of getting it correct, while you have a 3 out of 4 chance of getting it incorrect. So it would look like 1 over 4 here and 3 over 4 here. So just trying to say you might have different variations of a problem like that on the test. So if you work all those out, and I do actually want you to try them, you'll get 5.47% basically. Okay. All right, so last but not least on this one, part C. To pass the test, the student must answer 7 or more questions correctly. Would it be unusual to pass? Okay, so first of all, make sure that you remember that unusual means less than 5%. Okay, so notice we need to know the probability of 7 or more. So we're going to need the probability of 7, 8, 9, or all of them right. Okay, so that's going to be 4 combinations. Okay, and again, I'm just going to write them out, and you're going to need to figure that out. So the probability of 7 would be out of 10, choose 7. 7 correct, 3 incorrect, right? Out of 10, choose 8. 8 correct, 2 incorrect. Out of 10, choose 9. 9 correct, 1 incorrect. And then lastly, out of 10, choose 10. So 10 correct and 0 incorrect. Okay, by the way, that doesn't make that 0. Anything with the 0 power is actually 1. So, let's see, I got a janky 2 there. So remember, this is the probability for 7. This is the probability for 8. This is the probability for 9. And this is the probability for 10. By the way, remember, we're using combinations because order wouldn't matter, right? If you wanted to get 7 correct on this quiz or this test or whatever that had 10 questions, you wouldn't care which 7. You would just care that, you know, you got any random 7 of them right. So since order doesn't matter, that's why we use combinations, okay? So we get this, okay, and this is not unusual, right? This is not less than 5%. Okay, number 7. So this is 53% of people needed coronary bypass surgery, which implies that some of them did not, okay? So this is binomial. Okay, and the 2 choices here are either they needed the bypass surgery, so the probability of yes looks like 0.53, which means that the probability that they didn't need that surgery is 0.47. Okay, So let's go through these. What's the probability that exactly 9 of them? So the probability of 9 is going to be, how many did we sample? 15 of them. So out of 15, we want to choose 9. Okay, 9 needed it, which means that 6 did not, right? Because 9 plus 6 is 15. Okay, so notice these two numbers always add up to your total, always, always. Okay, but if you work that out on your calculator, you will get what's on the key, which I misplaced for a minute, which is 0.1780. The probability that more than 10, okay, so the probability of more than 10 is going to be the probability of 11, 12, 13, 14, and 15. Okay, so I'm only going to list a couple of these because I think we've done enough of these. So out of 15 for 11, I want to choose 11. 11 were a yes, which means by default that 4 were a no. Okay, and then for the next one, out of 15, I want to choose 12. So 12 were a yes, which means 3 were a no. Okay, so here I'm going to get lazy because I'm not writing all this out again. But this would be the probability of 11. This would be the probability of 12. So you would still have some work to do here. You would still need to figure out the probability for 13, 14, 15. But when you do that and you add it all up, you will get what's on the key, which is 0.0920. Okay, part C, what is the probability that fewer than 8? Okay, so I thought this would have been quicker, so I want the probability of less than 8. So especially since I already figured out a lot of these here, I did do it the opposite way. So I did 1 minus the probability of 8 or more. Because if you worked all this out, you already have 11, 12, 13, 14, 15. Okay, so all you really needed to do was, 8, 9, 10. So that's how I did it. You can do it however you want, but I'm just going to kind of start to set this up. So this would be 1 minus the probability of, so it would be out of 15, choose 8, 8 successes, and 7 failures. Okay, and then this one would be out of 15, choose 9. So we have 9 successes and 6 failures, and so on and so forth. Okay, so I'm going to be lazy there. I don't want to write it all out. But when you write it all out, you get 1 minus that, and you should get what's on the key, which is 0.4065. Okay, I know some of the problems on the review, included a lot of choices. I get that. Okay, so as long as you know the process, you should be good to go for the test, and the test is going to be a little more kind because the test has to be able to be finished quickly. So part D says, would it be unusual if all of them were over age 65? So out of 15, I want to choose all of them. So I have 15 successes or yeses and 0 no's. Okay, again, that's just 1. So you end up getting about 0.000073, which is definitely less than 5. So yes, it's unusual. Make sure that you know how your calculator handles really small numbers like that. So you might want to actually legitimately plug this in. And remember, you get to this by using the stat menu. Okay, so just make sure that you actually look it up. All right, moving along, number 8. All right, so more of the same kind of problem. So this is binomial because either they graduated from high school and went to college, or they didn't. So the probability of college is 0.66. So that means the probability of no college, or the opposite, is 0.34. And they did 30 samples. So I was really kind of unkind to you on some of these. So you might just have to kind of fast track some of these and maybe not work all of them out. The probability of 18 would be out of 30, choose 18. So there are 18 that went to college. So by default, that means there must be 12 that didn't. Okay. If you work that out on your calculator, you get 1166. Okay. What is the probability that more than 15 enroll? So I pulled these questions from the book. Okay, but again, I wasn't very kind. So the probability of more than 15 would mean you would do like 30, choose 16. Plus 30, choose 17. And then, unfortunately, you dot, dot, dot it, right? That's just too much to figure out. I'm not going to write all of that out, but I did figure it out at one time. Notice really going 1 minus doesn't really help you all that much because it's kind of the same either way. You either have to do 0 through 14, or sorry, 0 through 15, or you have to do 16 through 30. It's actually exactly the same either way, so it really doesn't matter. Part C, what is the probability that fewer than 12? So less than 12. So out of 30, I would choose none. So none went to college, which means they all did not go to college. And then we'll move on to 1. Again, if I'm going too fast through these, I mean, you can pause the video. You can also email me, but the concepts are, something we've covered before. So I feel like you should be able to kind of run through them kind of quickly with me. And so you should get 0, 0, 1, 0. Would it be unusual for 25 or more of them? So you need to find the probability of 25 or more. So that would be out of 30, choose 25. So 25 went to college, 5 didn't. Okay, or maybe 26. And then we're going to dot, dot, dot it all the way to 30. Okay, and if you work that out, this one is probably one you could actually work out. It's not crazy, but you get 0.03. So yes, that's unusual. It's less than 5%. Okay. Part E says, what is the mean number who graduate and enroll in college? So for that one, you would just need to use the numbers you got, right? Out of 30, there were 66% of them, so you just multiply them, okay? So it ends up being about 19.8. Okay, so a little bit less than 20. And then part F. What is the standard deviation of the number who enroll in a college? So we want the standard deviation. So you need to actually go and look at the formula for standard deviation for a binomial. And that is listed as, it's going to be square root always. And the formula for variance, at least, is value or number of cases times the success probability, but also times the failure probability. Okay, and that works out to be 2.5946. Number 9. All right, so for this one's a lot quicker. Okay, we're done with all the combination problems, thank the Lord. So on number 9, what is the mean number? So notice 81% of people said their jobs were stressful, 10 workers were chosen at random. So the first question is, what's the mean number who find their job stressful? So you're going to have to take the 10 people they asked times the 81%. So right around 8.1 people say they're 8.1-ish out of 10 say their job is stressful. For part B, we'll do just what we finished in the last 2 parts up here. So you do number times success times failure, and then take the square root of that. So it works out to be about 1.2406. Okay, number 10, you need to have your chart out. Okay, you're going to be using your chart a lot on this test, but this is the first one where we actually needed it. So I want you to find the area between these 2 z values. So for all of these, it's already given the z values, and all you need to do is find the 2 things that correspond with those from the chart. So I'm going to show you the first one on the chart, and then I'm just going to kind of run through them. So negative 1.28 and 1.36. So you start with the bigger one, the 1.36. So here's 1.3. Let me move my chart. Here's 1.3, and then you put your finger over, so it's 0.9131. Okay. So the first one is going to be 0.9131 minus whatever you get when you read the negative 1.28. So you got to turn the chart over. So negative 1.2, and then scroll over to negative 1.28. So it's 0.1003. For a difference of 81.28%. So on all of them, you just read the chart, take the bigger z value, and then subtract it from what you find on the smaller z value. So for part B, this is what I got. So really make sure you know how to read the chart. If you've been doing the homework and the quizzes, I mean, you should know how to read the chart by now. This one, I read these 2 values off the chart. And then lastly, I read 0.5279 minus 0.0143 for a difference of 0.5136. Okay. Remember, we read table A.2, the normal distribution, anytime we have a z-score, and then we read table A.3 anytime we have a t-score, or student t distribution. Okay, number 11. I think number 11 kind of warrants a picture. So actually, this is one of the ones that is usually kind of sometimes highly missed on test 3. So if you want to bound the middle 70%, you basically have a z-score of 0 here, and so you're trying to figure out what would give us the middle 70%. So what you really want to know is, what are these z-scores? Okay, notice this one's going to be a negative z-score, and this one's going to be a positive z-score. Okay, so what you really need to do is you need to find out what that z-score is. Okay, so if 70% is taken care of in the middle, then that means each of these sides is 15%. And actually, this is the number you need to read, because the chart, remember, always reads less than. So now you want to find the closest thing to 0.15 on your chart. So let's look at our chart and find the closest thing to 0.15. Notice we'll have to be on the negative side, right? So the closest thing to 0.15, it looks like there's 0.1515, so let me move my chart up. Here's 0.515, and then here's 0.1492, and that's the closer one. So it's 0.1492, which corresponds to negative 1.14. 0.1492, which matches with z equals negative 1.04, okay, which means also on the positive side it'll be positive 1.04. Okay, so notice that's what I asked you for in this one. I asked you for what z-score bounds the middle 70%, so that's all you do for that one. All right, number 12. So on this one, you need to make sure you read through the problems. If it says less than, you read the chart as is. If it says greater than, you're going to have to do 1 minus. So in part A, we want more than 13. Okay, so first you have to find the z-score. Z-score is always value minus mean over standard deviation. So we get a z-score of 0.56, and then because it's more than, we're going to do 1 minus what we read from the chart. So 1 minus what you read from the chart is what we have on the key, which is 0.2877. Part B is less than 15. So that means no adjustment on the chart necessary, but we do need the z-score. So value minus average over standard deviation gives you a z-score of 1.3. And just read the chart as is and you get this. Okay, the chart, again, always reads less than. If it's 1 or greater than, you got to do 1 minus that value. So the probability of between 10 and 14. So you're going to need to find z-scores for both. Okay, so the z-score for this one is going to look like 10 minus 11.5 over 2.7, whereas the z-score for this one looks like 14 minus average over 2.7. So the z-score for this one comes out to be negative 0.56. The z-score for this one ends up being 0.93. So now you're just going to find the values for both of these and subtract them, right? So you're going to get 0.8238 minus 0.2877, which is a difference of 53.61%. Okay, I'm just making sure that matches up with my key. My work's a little sloppy on this. And then part D, is it unusual for a baby to weigh more than 17 pounds? Okay, so first we need to find the z-score for 17. So it's 17 minus 11.5 over 2.7. Notice when the z-score is high, you have a larger or high or, you know, really, if it's really negative or really positive. And so we need to read what's on the chart, but we need to do 1 minus it since it was more than. So 1 minus 0.9793, which is right around 0.0207. So that is less than 5%, so yes, that's unusual. Okay, it would be unusual for a 2-month-old to weigh that much. That's a lot. Okay, so what I'm going to do is I'm going to split this review into 2 parts just because it's getting kind of long. So 1 through 12 is going to be on this video, and then the rest will be on a second video. That way, if you're trying to just kind of fast forward to find the question you want, you don't have to necessarily look for both.